Okay, welcome to this video 1.12. We're going to be looking at prime decomposition, which is a long word, but to decompose something, remember, is to break it down to its tiny pieces. Okay, so our learning goal is students be able to solve problems involving comparison, addition, and subtraction of integers, and that you'll be able to, at the end of this, decompose a composite number into its unique set of prime factors. Okay, right. So this idea of undoing numbers. Okay, so when we decompose a number, we are breaking it apart into its most basic pieces. Okay, so think of that idea as that living things decompose. So, you know, we had this nice tree, and the tree falls over, maybe, and then over time, tick tock, we end up getting this tree that rots away. Okay, and maybe bugs come and eat it. It rains down on it, and the wood rots away and becomes its sort of like individual pieces again, ready to become food maybe for another tree. Okay, so it's that idea of plants can decompose into the base matter that they're made out of that can be used again. Same way, numbers can be decomposed into the base pieces that kind of make it up. Okay, so every number, our key ideas, every composite number can be expressed as a unique product of prime numbers. Okay, so let's take, for instance, the number 30. Okay, it can be expressed as 2 times 3 times 5. Okay, now no other number is expressed like this. 2 times 3 times 5 is 30. That's its unique way of expressing its prime numbers. And you'll notice that both all of 2, 3, and 5 are all prime numbers, okay? And so that would be the prime decomposition of the number 30, okay? Right, a useful way to decompose a number is by using a factor tree, okay? We're going to use the number 24, and you'll see why in a moment, okay? So I'm going to go 24 is the number that I'm going to do the prime decomposition of, and we'll go 24 can be 2 times 12. Oh, 2 times 14, wow. 2 times 12. Now, 2 is a prime number, so we stop. Done. Right, let's move on to here. 12 still composite, so let's play with it for a bit. So 12 can be, let's go with 3 times 4. Okay, so you can put multiply sign in here if you want to. 3 times 4 is 12. 3 is a prime number, so now we move back to 4. So 4 is a prime number, so we're going to go so put 4 is composite, so what we can make up 4 with is 2 by 2 prime numbers. So once we've finished with the primes, so prime number, prime number, prime number, prime number, okay, so we can write down here that the prime decomposition according to this factor tree is 2 times 3 times 2 times 2 equals 24. Okay, now the reason I wanted to show you this, use 24 as an example, is if I put 24 here again, it's in a different colour, we can do this as 6 times 4. 6 can be 2 times 3. 4 can be 2 times 2. And now there's all my factors. Okay, my primes. And again, 2 times 3 times 2 times 2. Done. Now, well, that's equals 24. Okay, so with factor trees and things, it doesn't matter what sort of pair of factors you choose at the start, just as long as you sort of go through it correctly, you're still going to end up with the same prime decomposition. Now let's just have a look at this last little part. So now the convention for prime decomposition is to write it in ascending order in index form. Now this idea of convention is pretty important because it's kind of like the way we do it is so that everyone's doing it the same way. For instance, if you started writing and instead of a full stop you started putting a squiggly mark, and so you would write he walked the dog, full stop. Everyone would just be like, what is that squiggly space there? But so instead, to show the end of a sentence, we use the convention of a full stop, and everyone sort of has agreed to know what that means. Okay, so the same idea of prime decompositions, everyone's agreed to say this is how we show prime decomposition. and that is to write it in ascending order in index form. Okay, so it's really ascending order of the base, but, so for instance, let's take our 24. So we had it before as 2 times 3 times 2 times 2 is 24. So let's rewrite that with the factors being in ascending order. So 2 times 2 times 2 times 3 is 24. Okay, but we want to write it in index form. So we have 3 lots of 2's being multiplied here. So that will be 2 to the power of 3 times 3 is 24. And so that's how we write our prone decompositions, is in index form, ascending order, and sort of nice and neatly like that. Okay, so I hope that kind of made sense. You'll have plenty of time to practice these in class. Some of this stuff, we're getting into the things that maybe some of you haven't had a lot of chance to see before in primary school, and so I hope you're taking the time to make sure you do as much as you need to of the mustards and coulds to make sure that you sort of totally understand what's going on. Okay, so I hope you enjoyed that, and I will see you again at school. Thanks.